All right, I'm going to get started. This is lecture 14 of 1413. The lecture today is about attention. Okay, good. So where are we in this class? In this class, we talked a lot about preferences so far. Think about like preference of describing in economics. What do people want? What makes them happy in one way or the other? We talked about time preferences, risk preferences, and social preferences. Time preferences, how do people make choices over time? Risk preferences are how do people deal with risky situations when some things are uncertain and others are more certain, or like sometimes good things happen, sometimes not, and we don't, and there's a probability distribution over those events, and how does that affect how we make choices? And social preferences is what we talked about during the last few weeks, which is how does the presence of others affect our choices? How much do we care about others? And do we decide or make choices differently if others are involved? So now we've sort of done with preferences. It's sort of in some sense saying like, we know we have no models or ways to think about like what makes people happy. The second part, when you try to make decisions, is like when you look at your environment, like what are prices like, what do we know about others, what are our beliefs and what do we attend to, and how do we learn when we get new information? So what information do we have, and like what information do we attend to, and how do we learn when we get new information given to us? And so we're going to talk first about attention in this lecture, and then during the next couple of times, we're going to talk about beliefs and learning. So what we're going to do today is we're going to talk about three broad issues. One is we're going to provide you some motivating evidence about attention. We already had a little bit on this on lectures 1 and 2, but I want to sort of remind you of that a little bit. Then we're going to talk about two specific papers. One is a pretty famous paper by Chetty and co-authors on inattention to taxes. And then we're going to talk about a second paper, which is learning by noticing. In particular, we're going to ask the question of like, how is it possible that people do not attend to things that are important in their lives? Right? You might sort of say, well, if attention is limited, that's all good, but then we should sort of expect that people attend to really important stuff. So like, some sort of rational inattention models would say, well, it might well be that people are inattentive in some ways, but really it can't be possibly that the welfare losses from inattention are large, because if they were large, if there's things that people missed, then they would pay attention to those things and sort of shift their attention optimally. And the learning by noticing paper is sort of one theory, at least potentially, that addresses this question. The way these movie perception tests work is essentially they look for what's called change blindness. So the way this works is like often there's like one actor, which is like this guy here that I think you can see probably right now. There's like some guy who does some activity. You're supposed to watch the guy, and then there's like a second scene in some ways where the person does something else. In this case, the guy, sorry, where is he? The guy is taking a phone call. And so what happens then is, this is essentially then this guy that you see here then that takes a phone call is a different person altogether. And so that's called like change blindness, where essentially people then tend to not notice at all that now there's like two different people in a scene. There's other types of experiments that do this as well. But like one version of that would be like people go to like a bank. There's a bank teller, and these are like all sort of psych experiments. There's a bank teller. Where's the other guy? Here's the other guy. So like you see this guy, he looks actually very different to the other guy that you had seen before. So people go to the bank, there's a bank teller, the bank teller says, oh yeah, I'll have to just get something from the back. And then another person shows up who's like a totally different person, often looks very different, sometimes wears different things, and people just don't notice at all. And that's sort of the type of experiment is called change blindness. I've already shown you sort of the gorilla test before. I'm going to not play it again because I've already seen it, but essentially it's the thing where like people are asked like pay attention to how many passes people play in like a basketball game, and then there's a guy who's like in a gorilla suit who shows up and sort of like walks through the whole screen, and many people just miss the gorilla suit. Now, what's going on here? So there's a large number of these types of experiments. They're called change blindness or inattention experiments. And there's another version of that, which is, it's called the dichotic listening experiments. This is going back to Broadbent, 1958. They're essentially look something like this, where there's like people wear headphones with messages. There's on the one hand, this is like 1 hour left. There's supposed to be like ignored inputs, and on the other hand, are supposed to be attended inputs. So the person in the experiment is asked like, only listen to stuff that's, I guess, in your left ear. These are like the attended inputs. I'm going to ask you some questions about that. And then what you're supposed to then do is, oh. So what, can you still, are you still stuck? This is bad. Okay, so let me, 1 second, I'm going to unshare my screen. Exactly. Give me a second. So the way this works is like you would see, you would have headphones on, and you have like on one end you hear like inputs that you're supposed to attend to. On the other ear you hear inputs that you're not supposed to attend to. And then usually then you get explicit instructions to attend to the message in one ear, and then ask later about message in the other ear. People can't remember it. And then what these experiments often are, then when asked to keep a number in the head, people remember the played message much less. So essentially, what this sort of shows is that I guess, like people are pretty good at sort of shifting attention in some way, but attention is limited to the extent that like when you're also supposed to attend to something else at the same time, it's essentially like too much going on, and it's really hard for you to remember everything. And so that sort of tells us, to some degree, it tells us, I guess attention is limited. We tend to focus, when instructed at least, we tend to focus on stuff that's important, right? So like in the broadband experiment, if I tell you listen to the stuff in the right ear, you actually focus your attention to the stuff in the right ear. You miss the stuff on the left ear, so you can sort of direct your attention to stuff that you think is important, or like you've been instructed to focus on. So that kind of works. But at the same time, attention is limited in the sense of like, you can actually not remember what's in the other ear because you didn't attend to. So in some sense, it's not like you automatically remember stuff. You have to pay attention to things. And then at the same time, like when we now exogenously reduce people's attention by telling people to keep a number in the head or distracting them in some way, people are much worse at like even playing like the played message, the message that you're supposed to remember, and surely they don't remember the other message either. Okay. So then, in addition, which I already alluded to, attention is limited. There might be different factors that might affect people's attention. So what factors might be important for attention? It could be like your physical environment in some ways. It could be like it's really hot. It could be it's really cold. It could be other sort of like threats in the room. So like if somebody, you know, if you're in some place where like you're worried that there will be wild animals coming anytime soon. Your physical environment could be really important. It could be really loud. There's distractions. Could be like social media. It could be other stuff that you're just trying to do at the same time. Maybe you're trying to like solve some problems right now. Maybe you're trying to like prepare for some. For example, I had a phone call like just before our class. And I was also like trying to think about like what to do in class, and it's just really distracting to have like other things thinking about at the same time. Could be worries about others, your own or others' well-being. It could be sleep, or what people were saying already, like people's sort of physical environment. We're going to talk about some of this in the poverty lecture. So there in particular, like one thing that poverty tends to come along with is sort of a bunch of different ways of, in addition to obviously not having money and many other deprivations, poverty tends to come along with like lots of other factors that might reduce people's attention. And that's to do with like sleep, it's to do with like exposure to noise, it's coming with like worries about people's health and so on and so forth. There's some question about like practice, like can you actually practice attention? And there's some people who would argue, at least in education, maybe at younger ages, suppose you like sit kids down and have them like practice just focusing on tasks like multiplications or whatever, any math problems. Some people would argue in addition to just helping people learn math, like actually sort of like the numbers and so on and how to multiply, you might also actually just help students learn how to focus and how to pay attention carefully to things, in particular, like particularly sustain attention and not get distracted by other things. Other distractions, by the way, also are like temptations, for example. So if I put like a delicious chocolate cake in front of you and if you're really hungry, then it might be actually really hard to pay attention to whatever else you're doing just because that's really distracting to you. Okay, and so we're gonna, for now, keep sort of think about like attention being fixed. We're gonna get back to the issue of attention being malleable and potentially being depleted by issues such as poverty at the end in the very last lecture. But for now, we're gonna look at like, think about like attention is fixed but limited, and now we're gonna look at like what are the consequences of that. Okay, so then one question you might ask is like, well, you know, this listening task that I just showed you, or like whether like a monkey walks through like some video or the like, it's kind of like a pretty low stakes situation. Who really cares? And so the one Chicago view of economics would be to say, well, these are just low stakes situations, but you know, once stakes are really high, then people will surely pay attention. And so there's a number of different papers that sort of look at this issue, but one quite nice example here is from the stock market, and sort of arguably an event of like high economic importance because people make a lot of money potentially from it. So there's this very nice paper by Huberman and Reger from 2001, which has, it's essentially like an event study and a case study of like stock market development of a company called Entramed. And this company in 1997, on October, November, has very positive early results on a cure for cancer. Now, for any of these types of companies, like having like new cures and new sort of medications or vaccines or like are like hugely valuable because, you know, they can sell a lot of their product in the future, which means essentially positive news about that means, you know, you'll have lots, at least with high probability or higher probability, large profits in the future, and to the extent the stock market is an indication of that, the stock market, you might expect the stock market to go up. Now then, November 28, the journal Nature, which is a very highly prominent scientific journal, features these news very prominently, and the New York Times, in fact, reports on it on page A28, which is, you know, very much in the back of the paper. And on May 3rd, this is like a whole like 6 months later, the New York Times again features essentially the same story as on November 28 on the front page. Okay. Now, then on November 12, 1998, the Wall Street Journal front page then reports about a failed replication. Right. So essentially, sort of to say, well, there's a promising new early result. These early results are often like small samples, and it's not quite clear that they replicate really with like larger samples and so on. Is this really like a good cure? And so you kind of want to have replications, and really only if you're able to replicate your results is this actually something that's useful and that you can make money off. Now, what happened to the Entramed stock prices? And so the first question you might sort of say is, well, in a world of full attention with unlimited arbitrage, as in like if people took full advantage of like the news and reacted perfectly, what would we expect? And second, in reality, what did actually happen? So let's first ask the first question about with full attention, what would we expect? I guess there's a bit of a question what happens in the first one. There's a bit of a question, is there insider trading or who gets the news in the first place? So one thing you might say is, well, maybe the first one, only the company knows, and sort of maybe that's not public knowledge. And then if there's insider trading, maybe the stock market might go up. But surely, like in number two, if Nature prominently features it, there's going to be a bunch of traders, a bunch of people who like invest in this company or not. If they pay attention, they should really know what's going on, and they should really, the stock market should go up. Conditional on that, on the November 28 news, you know, on May 3rd, there's really no news here, right? It's not like we knew this before. If everybody was paying attention before carefully, the stock market should have incorporated, the news is out, sort of like traders know, like you should buy this, or like stocks that like that this company is going to be more profitable, so stock should go up. So really you should expect, if there's full attention, you expect nothing to happen on May 3rd, 98. And then if there's a failed replication, well, to the extent that like this means like this, this cancer queue is like entirely useless, the stock market should essentially just go down to where it was before. Now, but what about in reality? So let me actually just show you. So here's sort of the reality of this. So here's, there's not even like sort of, there's the previous events not in here, but like, so this is essentially the first story that comes out. You see a little bit of like an increase here, but actually quite a bit in relative terms by something like, 5%. It seems like people just didn't really quite notice what was going on. And there was also no trend upwards. It's not like the news was spreading across people and so on. And then there's like a huge jump now in the New York Times, like, right? So this is essentially here, it's in the New York Times, but in the back of the journal. Here, up here, it's essentially the New York Times, the front page, and suddenly lots of people pay attention to news that's actually not news because, that was already in the New York Times before, to the extent that everybody pays attention. If there's unlimited attention and unlimited arbitrage, we should essentially expect no effects whatsoever. So we see like a huge spike in the stock market price. Maybe the stock market overacted a bit and went down a little bit. But then what we see here is then sort of the negative effect of like the failed replication. Notice that here the stock market is still quite a bit high. The price is still quite a bit higher, maybe twice as high, about like 20 compared to like 10 as it was before. It's a little bit hard to interpret that because it could just be that, maybe there's still a chance that the cure might work out. Maybe there's other news about the company in the meantime that are positive and so on. But the key part here is like the fact that the stock market went up here on May 4th, 1998 really is sort of saying like, there's it's news for lots of people, and really it shouldn't be news. There shouldn't be any reaction because essentially it's old news, as you would say, in the sense of like people in 1997, in November 28 already reported all of that. Does that make sense? Okay. So, and there's lots of examples of these kind of things where essentially some of this is like inattention, some of this is also like confusion. I don't know if any of you have heard of what happened to the Zoom stock market price, So essentially, I don't know if any of you have heard of this story. So essentially, Zoom, there's a company, Zoom, which is the company that we're using right now to record this video. The stock market price of Zoom has gone up a lot during the last like 3 months, rightly so, because Zoom now has, Zoom's profits has gone up a lot. For example, MIT now has like a corporate license of Zoom, which essentially means like thousands of people now are using or can use Zoom, and that's an expensive thing to do. It turns out there's another company that's also called Zoom, except for that it's a different company and has nothing to do with the actual Zoom technology. It turns out that the Zoom stock market price for this other company went up a lot as well. The ticker for that company is actually SZOOM, so like Zoom, as opposed to like the actual Zoom company that we're using right now. Their ticker is like ZM. And so at some point, actually, the trading for that other company was halted, presumably because people were very confused and they were not really paying close attention to what is the right ticker, what's the right company that they're actually buying. They thought they were buying Zoom, like the actual online video conferencing company, while in fact they were just buying some other company that's actually not even doing anything anymore. So there's lots of stories about people being inattentive, even in situations when stakes are really, really high. Now then you might say, well, how do we now measure? So now in some sense we have sort of some evidence here that people are, in some sense, somewhat informal evidence that people are inattentive. Now, how would you measure the impacts of inattention overall? So if you wanted to sort of just measure and demonstrate that people are inattentive, in addition to what I've just shown you, what might you do? How might you do that? There's some information that they usually get in the world, and they should have. One example that we're going to discuss is like essentially prices or taxes. And now, if you want to demonstrate that people are actually missing those prices or taxes, what you can do is now you can make it very salient. You make it really apparent to people. And then you can look at, like, when you look at changes in prices, or the change of like making things from non-salient to salient. How do people react now? If maybe make, for example, taxes very salient, what happens to people's demand for certain products? And if then sort of making things salient changes people's behavior, that then sort of identifies underlying inattention. So if you just, people don't have access to certain information, in some sense that's less interesting, because that just means like, well, I don't have the information that's really available to me. But in some ways I could make information that's really very salient. I essentially could sort of reduce the salience, as you say, of certain types of information. Again, information that should be available to them. For example, like suppose I do like sales. If I'm trying to sort of, as a company, sell things, you go to a store, and usually sales are made very salient to people. Now you could essentially just change the prices without making these sales very salient, and then you could look at like how attentive are people to that. And in a way that's sort of in some ways less natural, right? Because when people are, in a way, what we want to demonstrate is that in people's real lives, there's information available to them, and they're not really paying sufficiently much attention to it. So if you can then sort of change that in some ways and sort of demonstrate that now they're changing their behavior, that must mean that previously they had been like misoptimizing. If instead you did something like, if you sort of reduced people's, the salience of certain types of information, that's in a way somewhat less interesting, because it would sort of say, well, it doesn't really mean that they were inattentive to start with. It's more like you're hiding something from people and now they can't find it. That's in some ways somewhat less interesting. But I think in principle, you'd also, exactly as you say, identify inattention. So there's a few sort of type of things that people have done. And there's, to be clear, there's often like a pretty fine line between attention and memory. So one thing we could do is, and this is what Maya was saying previously, you could make certain features like taxes very salient. That's what we're going to look at next. In addition, you can sort of like provide some information when the correct response is known already. That's when I talk about afterwards. It's the study by Hanna et al. So that's kind of like when people have certain types of information already, but then sort of providing that information again, or giving that information in some sort of concise form, and sort of essentially notifying people of the fact that this information could be or should be important. And when we now see people react to it, then that does mean that, like, that must mean that before they were like inattentive. Another thing that people have done a lot is like reminders. Reminders often are sort of like, you can think of these as like memory issues, and people just forget things. But in some sense, memory issues and attention issues are very closely linked, as in like, if you forget something, then you don't pay attention to something. So if I remind you of something, now you're paying attention to, like, for example, your savings or like your medical adherence, like you should take certain drugs and so on. There's a number of studies that essentially provide reminders to people. And if these reminders have effects, then that must mean that people were not paying attention to those kinds of things, often presumably because of memory problems. They just forget sometimes. Okay. So now let me sort of start with a very simple model to help us sort of understand the results from the Chetty et al. Paper. It's very simple and very sort of just a sketch, but I think it's actually helpful to sort of see what people are doing. So consider a good with a value of V inclusive of the price, which is a sum of two components. The components are little v and O. So there's a visible and salient component V, and there's an opaque component O, okay? And so if you're now inattentive, the consumer, or inattentive consumer, perceived the value, instead of perceiving the true value V, the consumer perceives the value V hat, which is little v, which is like a salient component. So even if you're inattentive, the assumption is like the salient part of the good you always see. For example, what color is the good or the light, you always see that. And in addition, the opaque component, the stuff that's not salient, you're only going to pay attention to with a fraction of 1 minus theta. So the degree of inattention, so theta is our inattention parameter, and theta sort of measures how much are you paying attention to stuff that's not particularly salient. So for theta equals 0, you're back to the cases before. For theta equals 0, v hat equals v, which is essentially just a standard case. if theta were like 1, so theta is supposed to be between 0 and 1. If theta is 1, then essentially you're not paying attention at all to the opaque component. And anywhere in between, essentially, then you're paying only partial attention to the opaque component. So the interpretation is like each individual essentially sees sees O to some degree, but processes it only partially to the degree of theta. Of course, whether you actually see it and not processes, or whether you sort of miss it entirely, it's in some sense like a philosophical question. But think about like everybody has at least in principle access to the component O, but they only process it and pay attention to it only to some degree. Okay, so Chetty now applies this model essentially to taxes. So one very interesting feature about some taxes is the fact that like sales taxes are only added at the register, right? So you, in some, at least in most cases, you would like shop and then in the store, and then the sales tax only at the end, once you actually go to the store, will be added. Now, people know when you ask people directly, what is the sales tax in your state, people actually on average pretty good at knowing this. So it's not like people don't know that there's a sales tax, but they might just forget that there are sales taxes for goods. So now what you can do now is like, you can compare the demand response to sales tax changes versus the demand response to other price changes, right? So like, if you see prices fluctuating in a store over time or across goods, presumably everybody sees those price changes overall if these are like price changes that are not related to sales taxes. The reason being, like once you're in the store, you're going to look at prices, you're going to see is the price high or low even before you go to the register. So presumably you see the price tag pretty much most of the time. In contrast, when you look at sales tax changes, if the sales tax goes up for some reason, or if there's a sales tax for some items versus others, you might just miss that at the time when you're sort of choosing the good before you go to the register. And once you're then at the register, you might sort of not even notice that you have paid the sales tax, or you might be surprised and just don't change your behavior anymore, but at least notice it. So now what do Chetty et al. Do? They have data on the demand for items in a grocery store. And they have essentially the demand D of V hat. Remember, V hat is the function of the perceived value, which I showed you here before. Let me go back for a second. So you see V hat here is like V, which is the scaling component, plus 1 minus theta times O is the opaque component. So the demand for goods depends on the perceived value V hat that people have. And there's a visible part has the value V, which is inclusive of the price, right? So when you look at like, when you're in a store, you look at the good, you see whether you like it, you see the brand, you see the color, and so on and so forth. You also see the price, right? So like the valuation that you give, or the value V that you draw from that is essentially coming like how much they want to have this thing, minus kind of like the price that you see, which goes into the visible part of the evaluation. And then there's a less visible part, which is just stuff that's essentially hidden. And there's a bunch of different parts to that you might not pay attention to, which could be like ingredients or the like, or is it like organic or not and the like. But in particular, the sales tax, right? So like when you think about evaluation, you would have to like essentially however much you like the good, you have to sort of subtract the sales tax because you have to sort of pay taxes on that good. And that's sort of less visible to some people. So you might sort of not pay attention to it. So in this case, it'll be V hat is like B, now the visible component, plus 1 minus theta times O, and that's just repeating what I showed you before. And that equals V minus 1 minus theta times TP, which is the sales tax. And now, to the extent that people pay attention to theta, the sales tax might matter more or less. Okay. There might be other sort of opaque components that are unobservable both to the experimenter but also to the person. We're going to abstract from that. So for now, we're going to essentially say the less visible part is only the state tax. Okay. Any questions on this? Okay. So now, and this is sort of like, so now essentially what this gives us now we can essentially try to see if we have sort of this, how can we identify this parameter theta by making things very salient. And so the idea is now to make the tax fully salient. Let me show you how this looks like in practice. Here's some math, but I'll go back to this in a second. Let me just show you what this looks like in the experiment. So the idea in the experiment is to say, you see on the lower part here, you see like a normal you see an original price tag here. This is what the price tag usually would look like. So this would be an item, I guess this is like brushes. This item would cost like $5.79 usually. And then what they did in the experiment, they essentially added a tag where they said, now here, $5.79 plus sales tax is $6.22. And now we make it like entirely salient that there's a sales tax, and we make the true price very salient. Okay, and now the question is like, if we do that, if we go from like theta being like, for example, say 0.5, you only like partially observe the sales tax. If we go from that to making the sales tax fully salient, what happens to people's demand, and can we infer from that theta what theta is actually look like? So let me sort of go back to this. So essentially, what we're trying to look at, a change in demand when theta falls to 0. Why does theta fall to 0? The assumption here is that whatever theta people have before, so you might sort of partially or even not at all, theta might be like 0.5 or 1 or whatever for people. But now the intervention that I just showed you brings theta down to 0, right? Because now I make it fully salient to people what the sales tax is. And so the question is like now, can we have an expression for the change in log demand when theta falls from whatever is before down to 0? So now what we have is the change in log demand is the demand that we had before. This is what I showed you before. This was essentially demand as a function of V. Remember what I showed you here before? Give me 1 second, I'll go back. So what I showed you here, demand is like function of V hat, and V hat is this animal here. It's V minus 1 minus theta times TP. And now the question is like, what happens to demand when, or log demand here, forget about the log, that's not that interesting, that's just for math. So here's the demand as a function of what it was before. And here's demand when I now make things very salient, right? So now here, in this case here, theta equals 0, and here theta is whatever it had been before. Now, when you have this expression, what you can do is you can sort of linearize that, sort of take the derivative and sort of say, what is this difference? Well, this difference is, and you can sort of do the math, that's essentially theta times TP. And then here, this is the derivative with respect to theta. And what this gives you essentially is that the change in log demand is a function of theta, a function of tau, which is like the tax, and eta, which is the price elasticity. So essentially that's to say is like, if we have now an intervention where we can look at how does demand or log demand change when we do this intervention, assuming that this intervention brings theta from whatever it was before down to 0, we can look at like now what happens to demand, that's delta log demand here, that's sort of just a definition, and we can have that, that's an expression of, we can relate that to theta, to T, which is like the tax as it is, that's something like 7%, and then eta, which is the price elasticity of demand. So that is to say, if we have this change in demand that we observe from changing theta down to 0, and if we had the price elasticity from like just other variation in prices that we see in the world, and if we have T, which is just how much the tax is, that would allow us to identify theta. And that's kind of like what the experiment is trying to do. So that implies essentially, so we can just rearrange this, we can just say theta is, I'm just sort of rearranging things, is minus the change in log demand from this intervention divided by T times the price elasticity. Okay, and that is just to say, essentially what we're trying to see is like, intuitively, that's just to say is like, once we make things very salient, going from like things not being salient to start with to making things very salient, how much does demand change there? And then we can look at like, well, so in this case, I guess this is like the tax is made very salient. And then we can look at like, well, how does this compare to other changes in prices? Assuming that essentially people are paying attention to prices anyway. So if you look at like things becoming more expensive by like 1%, how much are people changing their behavior there? And now we have to sort of take into account that like what's being made salient here is the tax T, and sort of from backing out the relative changes in demand for like usual price changes versus making things salient, we can now try to measure theta as like how much did they pay attention before. So one way to say this is like, for example, if we made things very salient and the change in log demand there's no change in log demand, what does that imply for theta? What we learned from that? Suppose the change here in demand is 0. People did not change their demand at all when we make things very salient versus what it was before. So, or put differently, if theta equals 0 here, then these two expressions are the same, which essentially means that this thing here is also going to be 0. So essentially, to the extent that our intervention changes large or induces large changes in demand, that must mean that essentially people were very attentive to start with. Essentially, if I'm making the prices very salient and nothing happens, well, that means like people were already paying attention before. Now, in the maximum case, if I'm sort of like, if people were paying no attention to prices as before, what would happen then? Well, in that case, I guess, oops, sorry. In that case, theta would be 1. So essentially, it would just be going from, we would look at like, what's the demand or change in demand from going like V minus TP to V, which is essentially just a change in TP. So that would be essentially say if the tax was like 7%, now we just have to look at like, what is the equivalent effect of like a 7% increase in the price, which is exactly what we have here. So essentially, just to summarize, and I think the math is in some sense not that interesting, but essentially to summarize, it's like the larger our reaction is to this intervention, the more inattentive most people have been before, because if they're inattentive to start with, they react more to making things more salient. So let me sort of show you what this looks like in practice. Again, like the goal here is to estimate the change in demand from making taxes fully salient. Again, here's the original tag, and here's like the sort of the experimental tag. It's very, very salient, very, very clear, and very hard to miss for people. And the assumption essentially is that people pay now full attention to this new tag. They have like a 3-week period in which this is like an experiment in California. They have a 3-week period in which they modify price tags of certain items. So they go essentially at different stores, they pick one store, and then essentially they modify the price tag only of a subset of randomized goods. And they make the after tax price salient in addition to the pre-tax price. Right? The pre-tax price is already very salient here. In addition, they make the after tax price very salient. And now they're going to do what's called like a triple diff estimate, which is in some sense a very funky or fancy word to just say what we're going to do is we compare the sales or like the demand during the treatment period to like the following. So there's a treatment period. We're going to compare how much of certain goods is, that have been treated, how much do the sales change compared to like the previous week sales for the same items. Second, we're going to compare them to sales for items in which the tax was not made salient. So there's some goods in the store for which the tax was not made salient. And then finally, there's going to be like control stores, right? So we're going to look at essentially in the stores that receive the treatment or in the store that receives the treatment, what happens to the goods that receive the treatment compared to the goods that don't receive the treatment. We compare that to like demand before the treatment was enacted for both of those types of goods. So essentially, what's the relative change in demand for the treated versus the non-treated items before versus after? So that's essentially what people would call like a diff and diff, like difference in differences. And in addition to that, we compare that difference in differences to the same difference in differences in the control stores. Let me show you exactly what this looks like. So this is a bit of a messy table or like a table with a lot of information, but it's in fact quite simple. So what we have here is like at the top is a treatment store, and at the bottom there's like some control stores. So in the control stores, nothing has been changed. So there's no experiment, there's no additional tags and so on being added. In the treatment stores, there's going to be control categories and treated categories. Notice that they didn't fully randomize all the goods. So it's not like if there's one brush next to another, one brush has like taxes versus not. Presumably because there's like, they're trying to minimize spillovers in some sense. If you only make this tax salient for one good that's next to another good, people will get very confused because they're like, well, why does this one have like taxes made salient and then the other one not? So now this is like across categories where people maybe only pay attention to certain goods in certain categories to start with. So what we're seeing here is now, here, these are like the control categories and the treated categories. And we can look at what's called the difference in differences. We can look at the change in demand in the treatment stores. What we're going to look at is like essentially the change in demand in the control categories and the treatment categories. So what we see here is like we can compare always the how much is sold in the experimental period, which is like this row here, compared to our baseline. And what we see is essentially demand in the control categories was going up a little bit by 0.84. That's just because of seasonality. So maybe people like were just buying more anyway for whatever reason. And in the treated categories over the same period, comparing essentially the experimental period to the baseline period, demand went down. So now the difference in differences estimate is essentially the change in demand in the treatment stores, comparing the treated categories compared to the control categories, which is just the difference between this column and this column, which is minus 2.14 units. Okay, so that's essentially how much did the demand change before versus after in the treated categories compared to the same change in the control categories. Okay, so that's essentially like difference in differences estimator. Now they also have the control scores. Why would we want the control scores as well? Why is that helpful to have? Suppose like that included like sunscreen and now it's getting like warmer, it's really like hot and everybody goes out and buys like sunscreen, then you see essentially people's demand or the control category or the treatment category goes up by a lot or goes down by a lot for whatever reason. Or suppose it's like, you know, umbrellas and one week was really like rainy and the other one was not rainy. And we see now essentially sort of seasonal or other sort of differences over time in some of the categories that would, even if it's randomized, it could just happen to be the case. So that would not have to do anything with the sales tax being salient. That's just sort of by chance. So now it's very nice to have some control stores where we can look at like the same difference in difference estimates. In some sense, think of the control scores in some sense like a placebo. We can do the same things. There's going to be the control categories and the treated categories. Notice, to be very clear, in the control stores, the treated categories do not receive any actual treatment. So we can do the same difference in differences. And what we see here is now that there's essentially no difference here. So the demand in the control categories went up a little bit for whatever reason, and the treated in this is a little bit smaller than in this other store. This difference is not statistically significant, but anyway, the control categories go up a little bit. The treated categories go also up a little bit. When you do this difference in differences estimate, you will find essentially no difference. Like in the control categories, there's no change in the treated categories compared to the baseline compared to the control categories. So difference in difference estimate in the control categories essentially is 0. And now what you can do is essentially is the difference in differences estimate. You can compare, you can now subtract this number here minus this number here, which gives you the triple diff estimate, which essentially is the relative change of treatment versus control before and after in treatment versus control stores. It's a little bit sort of like lots of differences in your head, but I hope this comparison from the table makes it clear. Any questions on the estimate or the procedure that they're doing? Okay, so what we see here now is essentially now making these taxes salient in the treated categories in the treatment scores reduces demand, right? Because essentially demand goes down. Why does demand go down? Well, like the perceived price that people face has now gone up. And now they buy less of these goods, presumably because before they were not paying attention. Now the price goes up and now essentially demand falls as it should because now things are more expensive. Now, and this is here the results, the average quantity sold decreases by 2.2 units. This is units of the goods relative to a baseline level of 25. That's an 8.8% decline. And now we can sort of use our little formula and sort of compute the degree of inattention. Essentially, now we can sort of say, okay, now we know, what the tax. So we know what the tax was. The tax was like 7.375%. We can estimate the price elasticity in some other ways. Essentially, we can say what happens if prices go up by 1%. For other reasons. What if the salient component that's already salient goes up? This is week by week variation across stores. So if the prices go up, what's the price elasticity? And the estimate of those price elasticity is also given from other variation. That's 1.59. And now we get essentially back out theta. Essentially what we're trying to ask is like, we have a change in 2.2 units that is making prices salient. Now the question is like, well, how large of a change is it relative to a change in prices of like 1%, 2%, and so on? We know that essentially the price elasticity is like 1.59. So we can essentially just back out theta. And so what we get from this formula now is that theta is about like 0.75, which says that consumers react to price changes due to sales tax changes only a quarter as much as to other price changes. So essentially, consumers are very inattentive, in fact, to sales taxes or sales tax changes. In fact, they only sort of perceive like a quarter as much as any other price changes in the world. Okay, and that sort of says, that's really saying like, look, people really seem to be missing these things that are not salient. Now, if you make them salient, people change their behavior. Therefore, they must have been inattentive to start with. In addition to that kind of evidence, Chetty et al. Also have some evidence on sort of using non-experimental variation. And in some sense, you could sort of say the evidence that I just showed you from the store is a little bit weird because in some sense you see these different tags and maybe the tags like raise attention to the price even regardless of the tax and sort of, it's a little bit weird in some ways. So it's quite nice to have some complementary evidence of like non-experimental panel data variation. So what they do is they look at beer consumption, and it turns out beer, and tobacco and other sort of types of goods have two types of taxes levied on them. They have like an excise tax, which is included in the price. This is highly salient during the choice process because essentially it's in the price already. So if like taxes go up, essentially the price goes up and people will notice if they pay attention, or since they pay attention to prices, since they're like in the price tag already. And then there's a sales tax. This is the tax that we were just talking about before. That's essentially very opaque during the choice process, as we just sort of showed. And now we can look at like variation across states and over time of like changes in excise taxes and sales taxes. And we can look at how much do people react to excise taxes relative to how much people react to sales taxes. And that relative reaction will tell us again something about theta. And what Chetty et al. Finds, and here's a table for that, is essentially when you look at changes in excise taxes, this is a tax that's very salient. The price elasticity, or like the elasticity is about like 0.8 to 0.9. So essentially, when the price goes up by 1%, people react by about like almost like 1%. In contrast, and there's some differences in like estimates, but once you control for things properly, people essentially do not react to the sales tax at all. Maybe a little bit, but overall the number is like very, very low. And now essentially the ratio of these types of reaction tells you how attentive people are. So essentially if you sort of divide, say, for example, if you took like the column number 3, if you divide 0.003 by 0.86, and you have to do a little bit of additional math that's sort of uninteresting, you essentially will get a result that essentially people do not pay attention to sales taxes. Their 1 minus theta is essentially close to 0. Put differently, the degree of inattention is almost 1. Theta is almost 1. So essentially people do not pay attention to these types of taxes. Inattention is almost complete. So there's substantial consumer inattention to non-transparent taxes. So what I showed you so far is essentially existence of inattention. It doesn't say why people are inattentive. It could be like people are just can't do the math in their head. It could be like people don't want to bother with it. They sort of say, well, it's kind of like a small change, so why do we really care? It could be that people are like, who buy alcohol half of the time are drunk and they don't pay any attention. They sort of know modeling in any way of like, why are people doing this? This is just saying like, it shows the existence of inattention in those kinds of consumer choices. It doesn't say why people are inattentive. And you might sort of say, well, 7% of a tax is kind of a small distortion. So like it might be actually optimal to miss that, which, you know, is a reasonable approach. It is probably quite a bit of money and quite a bit of distortion. If you think about it, you actually, 7% is not nothing. But, you know, if you like have a lot of money anyway, you might as well just not pay any attention to that stuff. And if that sort of helps you pay attention to other things. Notice that even then, that sort of shows that like the existence of inattention. It's just a bit of a question, kind of like how important is inattention? And this actually gets me to the next point, which is a question of like, why should we care about inattention to taxes? Why is that important or interesting potentially? The question exactly is like, who's paying attention, who's not paying attention, and then who's sort of like distorting their behavior potentially. There's lots of interesting issues about like heterogeneity and like who's paying attention. Like, but let me talk about this in a second. Let me ask differently, like, why is it that some taxes, the excise taxes, are very salient, and why is it that other taxes are not salient? Like, what do you think about like that? Is that an accident, or why is it that the taxes for alcohol and tobacco, etc., are like very salient? And why is it that other taxes for like shampoo or whatever are actually not salient? So one, there's sort of there's several objectives. If you took a public economics class, if you took John Gruber's class, but also if you took like 1401 or 1403, the reason why the government levies taxes is one big reason is to generate revenue, right? The government needs money, somehow we need to tax people. And issue is, of course, is that if you levy taxes on some goods versus others, that can distort consumer choices. And there's essentially sort of some theorems about like, and some considerations about like, which goods should you tax? And ideally, you would tax goods that people are consuming anyway. Essentially, what you want is like people make, so essentially when you have taxes in some goods but not in others, if people have different price elasticities on some goods versus others, and if you increase the good of one good or all goods by like a certain amount, if people have different price elasticities, then you might sort of distort their behavior, right? So if you increase, if you start taxing one thing and not another, people might sort of shift to the other good. And we don't want that because presumably people are already optimizing to start with. Now, if people are inelastic to certain goods, if like people need certain goods anyway and they buy them anyway, if they're inelastic, essentially there's a public economics would have tell you, or like some theories would tell you, you should tax these goods more. Now, distortion, when people are, so the distortions are lower if people don't fully react to taxes. That could be, for example, if you started taxing bread, for example, while everybody, or certain goods for like, or potatoes, where everybody needs to buy these goods anyway because people need to eat. Well, then there would be very low, people would be very, these goods would be very inelastic. Now, and that's because they need those things, not because they're inattentive, but just because they need these types of goods. Now, there's obviously like issues with like poverty, or we don't want to tax the poor too much. But in general, we kind of want to tax things that are inelastic. And so in a way, if people are inattentive to the taxes, in a way that's great because now they're not distorting their behavior and we can still get money from them. So in some sense, actually, some of the inattention for that purpose might be actually good because now people are not distorting their behavior by looking at those prices. So being inattentive in some ways is good. But exactly as Maya was saying, was like for some goods, and these are often labeled as like sin goods or the like, where there's either externalities or internalities. For example, if you think about like tobacco or alcohol, there are externalities. Tobacco, for example, secondhand smoking is bad for others. For alcohol, there's often externalities in terms of like drunk driving or violence or the like. So the government wants to sort of increase the price of alcohol because when people are making choices of how much alcohol to buy, they might not take into account the effects of alcohol on others. By internalities, I mean like people might not necessarily take into account the effect of alcohol or tobacco on themselves. This is what we discussed previously. This could be because of present bias. This could be because of biased beliefs or the like. Essentially, people might sort of hurt their future selves, and the government might sort of say, well, let's increase taxes because their future selves, people might like that. That might be a way of helping people, for instance, deal with self-control problems. So here, the government explicitly wants consumers to react to the taxes. The point is not to make money from people, and in fact, sometimes you're worried about making too much money from people. The point here is really to change behavior, to reduce the behavior that are being taxed. So you want to make such taxes particularly salient. And when you now look at sort of the taxes on alcohol versus the taxes on some of the excise taxes versus the sales taxes, the excise taxes are precisely salient because we want people to react to it, while the sales taxes are not. Of course, there's variation across places, but it's not an accident that we see this in the world the way that is. Now, one thing that's quite interesting now is, and I think Jose was, or William was saying that, it's like when consumers are heterogeneous, then there's a lot of quite interesting issues. For example, if you had like the poor pay more or less attention compared to the rich, or if only like a subset of people pay attention to those goods, then in a way you would sort of find that the average elasticity is still quite low, but some people are actually distorting their behavior quite a bit and others do not. And you know, that gets relatively quickly quite complicated. And you know, you could sort of then get into situations where you make some people a lot worse off and some people better off for making something salient versus not. Any questions on all of this? Okay, so then we get to the next question, and this is sort of getting a little bit at the question that was asked previously about can inattention or attention have large effects? And so, you know, on the one hand, you might sort of say, well, you know, people's choices, for example, consumption patterns are distorted due to limited attention. But, you know, you might sort of ask, well, you know, if it's really true that like people's consumption patterns are really distorted that much, if I'm like so much worse off by like not paying attention to things, well, eventually I'm going to notice this, somebody's going to tell me, or like, you know, in a way, like I notice myself eventually that like I'm doing things really worse compared to my friends. And eventually, if things are really distorted like a lot, I might sort of pay attention to it. So that the underlying idea is that like potentially people are rationally inattentive in the sense of saying like, look, people's attention is limited in some ways, but it's only it's optimal for people to pay attention to things that are really important. And there the underlying question is like, what is salient to people and how do people decide what to focus on? And won't people pay attention to important things anyway if they have to? And so then the question is like, well, how is it possible that inattention could have like large effects anyway? And so the next paper is like a good example of that. And here's like a very intuitive example of why that might be. So consider the following situation. You have been getting headaches, you go to the doctor, and the doctor asks you like whether it gets worse after eating certain foods. And so what are you gonna say? Well, the answer will probably be like, I don't know. And why is that? Like, why might you just not even know the answer to that question? An underlying theory in your mind of like why you might be getting headaches. And, you know, you might just not have a theory that it's related to your food consumption. So you like, while you have lots of data in front of you, you eat every day, you get headaches on some days and not on others, you could surely pay attention to it if you wanted to. But it's not even like a theory in your mind. So like you're not even like encode the relevant information. If you don't expect to have food allergies or like gluten or allergy or the like, if you don't expect that to be a likely cause, then you're never going to actually pay attention. And you get like infinite amounts of data on like every day on headaches and food consumption, but you're never going to notice because you don't have a theory in your mind that that might be the case. Now, and so there's a relationship between attention and memory. You only remember or pay attention to stuff that actually are theories of yours, and then you only remember those things that you actually paid attention to in the first place. And so selective attention then may have persistent effects on what we learn. Essentially, you could have like unlimited amounts of information in front of you, and you will never learn because you never just had it on your radar that this information is actually relevant for the issue at hand. And Josh Schwartzstein has a very nice sort of model that illustrates that. Another example is like for medicine, it's many women died from childbed fever at hospitals in the mid-19th century. The popular theories were like bad smells at the hospital, presence of male doctors wounded the modesty of mothers. That's of course nonsense. And the true explanation is germs. Doctors didn't wash their hands. And again, like in some sense, that's not a tricky thing to figure out if you have the idea, if you have the hypothesis or the sort of the idea that this could be important. And presumably some doctors were washing their hands anyway, sometimes not, and they would have a lot fewer deaths. But nobody was noticing because nobody was paying attention. So once you have sort of the right theory in mind, then you can test it, and then of course you can gather the right information and pay attention to the right information and learn. Now, and sort of the basic model from Josh Schwartz, beliefs today matter for what is being attended to today, which then affect people's beliefs tomorrow. And now, if you don't attend to the right things, if your model of the world is the wrong model, you might never learn to attend to important aspects of the world. And so then forecasting beliefs may be biased and persistently biased in a systematic fashion, and you might persistently misreact and misattribute causes to unimportant variables because you have never even considered the idea of the correct model of the world. And so now the paper I'm going to show you is sort of an example of that. This is seaweed farming in Indonesia, which is not immediately obvious why that's related, but I'll show you in a second. So this is what seaweed farming looks like. I'll do this relatively briefly, but essentially it's like at some beaches, you can like grow seaweeds in like these rows. And you see these round things here, which are essentially pods. And so there are many factors are important in seaweed farming. Essentially, they're these pods, which are essentially these round things that you see here, they're essentially grown in different lines. And so if you're seaweed farmers, what's really important is like line spacing, or potentially important is line spacing, pod spacing, and pod size. How big are these pods? Now, how does seaweed farming actually work? I've never done seaweed farming myself, but apparently this is how it works. So farmers use what's called the bottom method, which is they drive wooden stakes in shallow bottom near shore, and they attach lines to these stakes. And then they take raw seaweed from the last harvest and cut it into pods, either like these kind of roundish things. And the pods are planted by attaching them at a given interval on the lines in the sea. And at low tides, farmers tend the plots. And sort of the seaweed is then harvested after 30 to 40 days. And so now many of the dimensions could matter: the pod size, the distance between the lines, the distance between pods, timing, and so on. One nice thing about seaweed is there's many different pods. You can actually try and learn and estimate the importance of these factors over time if only you paid attention. Okay. But the question is kind of like, which of these factors are important, and are people paying attention to those factors? So let me, and so what the experiment now is doing is there's lots of farmers in the experiment. They're quite experienced. They've been doing this for a long time, 18 years of farming. Many of them are the vast majority illiterate. So these are people who should really know what they're doing in their seaweed farming experience. And so the enumerators went to visit these farmers and to measure and document their farming methods. And when you ask them about their current pod size, and you just ask them how big are your pods, people just don't know the answer to. They also don't know the answer to what's the optimal pod size. When you just ask them how big are your pods when you plant them, they don't know. When you ask them what's the best way to do it, they don't know. Importantly, they know exactly the answer to other questions. They know the length of the typical line, they know the distance between the lines, and they also have very clear ideas of what's optimal to do so. But they seem to essentially neglect the pod size dimension entirely when they're thinking about what to do. And so in the experimental trial now, they did essentially different treatments, and the treatments were essentially such that farmers were provided experimental variation in the different pod sizes, and essentially induced to experiment with pod sizes. And in some cases, farmers were just left on their own. They were just induced to do this experiment. And the question was like, now, will farmers learn from their own in this experiment? And then in addition, they also have like an information condition where they then sort of summarize that information to the farmers in addition. So, so the question is now, once farmers are induced to experiment, you surely would think that farmers would learn now that they're given all the information that they need. And like, here's the different pod sizes, Here's the different profits that you get from the different types of pods. Now they might sort of learn on their own. But if you don't attend to pod size in the first place, if you think it's kind of like irrelevant anyway, even if you have induced to do the experiment, you're not going to learn at all. And so then they did essentially these follow-up surveys. I'm going to just skip. So now what they do is they also do like an information provision where they essentially tell farmers that the weighting they were doing with everybody, but in addition, they also provided information and did some simple calculations on like which is the best combination of pod size and distance. Notice that farmers are literate, they're able to do this on their own, but the experiment was sort of like just providing this information to farmers explicitly with a recommendation about like what's the pod weight and what is the optimal distance. And so now what the experiment finds is large gains from the changing the farming methodology, and sort of the trial participation itself only has an insignificant effect. That's to say, if you in addition then summarize data for people, has a much larger effect, essentially sort of like focusing people's attention to things that they should be already know, changes their farming behavior a lot. And that's essentially evidence that people were not paying attention in the first place, even if you make them participate in a trial where they should have really or could have at least learned things on their own. And there's large impacts of the trial if the data from the trial is presented to farmers. There's no impact of the trial on dimensions that farmers had already noticed previously, presumably because they're already paying attention and were optimizing. So now what did we learn from this? And let me quickly sort of summarize and let you go. So we have systematic learning failures even though all information was available. So farmers simply did not pay attention because they didn't think that pod size was relevant in any way in their lives. Now, and that's sort of a potential explanation why people might not pay attention even to important information, because if your model of the world is just wrong, why would you even think that this is important? And the problem here is then like there's never an opportunity to actually learn. You never even collect information that might reject your model because you're convinced that your model is right in the first place. And so then, lack of attention might generate arbitrarily large welfare losses. You can really screw up big time for a long time and never really change your behavior because essentially you never learn, you never even pay attention to any information that you might have available that says your model is wrong.